Manufacturers publish specification sheets for every product, but today we'll challenge your engineering intuition because specifications don't always tell the whole story. Today we're pushing this eco-worthy system beyond its published specifications to see how much performance is actually hiding behind the numbers. I've paired eco-worthy's new 24-volt 100 amp hour lithium battery with their 3000 watt pure sine wave inverter. Now, this isn't a standard product review. This is a real-world stress test. Let's look at the specifications so you can make your official prediction. The battery has a nominal voltage of 25.6 volts, a capacity of 100 amp hours, and stores 2,560 watt hours of energy. The specification that matters most today is its listed 100 amp maximum continuous discharge current. The inverter is rated for 3,000 watts continuous with a 6,000 watt surge. Now here's the math problem. A battery supplying 100 amps at 25.6 volts can only deliver about 2,560 watts. Yet a 3,000 watt inverter requires more than 3,000 watts from the battery to account for losses because no inverter is 100% efficient. On paper, the battery appears to be the limiting factor. So now it's time to lock in your prediction. Will the battery's BMS shut down first? Will the inverter's overload protection trip first? Or will both products exceed their published ratings? Drop your prediction in the comments. Everything is wired with heavy gauge cables and protected by a 200 amp fuse. Because this equipment is expected to be pushed beyond its published ratings, the testing was conducted outside where everything could safely be monitored. To generate a large, controllable load, I'm charging 3 battery systems at the same time. First, an eco-worthy 48-volt wall-mounted battery. This battery will be part of an upcoming project to try running an air conditioner in my garage completely off-grid using solar panels and eco-worthy electrical components. Next, a Lithium 12-volt battery, and finally my EcoFlow Delta Pro 3. By adjusting the Delta Pro 3's AC charging input, I could precisely dial in the total load I wanted. That means nearly all of the energy produced during this test is being stored in other batteries, apart from normal conversion losses. The inverter output was monitored using its remote display, while battery voltage, current, and DC power were measured using a Victron smart shunt. For this test, a successful sustained load had to operate continuously for at least 2 full minutes. Now, let's go straight to the results. The first test targeted the inverter's published continuous rating. I dialed the load up to 2,995 watts. The inverter didn't even flinch, holding that output for more than 2 full minutes. Meanwhile, the battery held 25.12 volts while delivering 141.3 amps or 3,549 watts of DC power. Right away, something surprising happened. The inverter met its published rating, while the battery exceeded its listed 100 amp specification by more than 40 amps, without even hinting at shutting down. Round 1 goes to the hardware. Next, I increased the load. The inverter climbed to 3,202 watts, roughly 200 watts above its published continuous rating. The battery held steady at 25.10 volts while supplying 149.77 amps and 3,759 watts. Once again, the system completed the full 2-minute test. No inverter shutdown, no battery shutdown. At this point, the battery was supplying roughly 50% more current than its published specification. But now, it was time to find the true limits. For the final test, I turned the load up one last time. The inverter reached 3,466 watts. The battery continued delivering 168.42 amps and 4,195 watts of DC power. Honestly, I was not expecting that. The system continued running for approximately 30 seconds until the inverter's overload protection safely shut it down. But notice what didn't happen. The battery never disconnected. The inverter reached its protection limit first. The battery's performance under this level of stress was honestly the biggest surprise. A fully charged 24-volt lithium battery typically rests around 26.6 volts. The moment I applied nearly 3,000 watts of load, the voltage dropped to 25.12 volts. That's completely normal, but here's what impressed me. As the current increased from 141 amps to more than 168 amps, the battery voltage fell by only another 0.2 of a volt, down to 24.92 volts. That remarkably flat voltage response suggests the battery has very low internal resistance and remained extremely stable under an exceptionally heavy load. Now let's look at efficiency. At 2,995 watts of AC output, the battery supplied 3,549 watts of DC power. That gives us a measured total system efficiency of approximately 84.4%. EcoWorthy rates the inverter itself at greater than 90% efficiency. So why is our measured number lower? Because this measurement includes the complete high current DC path. At more than 140 amps, measurable power is lost through the battery cables, terminals, the smart shunt, and the 200 amp fuse before the power ever reaches the inverter. This is the efficiency of my complete test setup, not just the inverter itself. Going into this test, the specification sheet suggested the battery would be the limiting factor. Instead, it supplied more than 168 amps without cutting out, while the inverter successfully delivered 3,202 watts for more than 2 minutes before protecting itself at 3,466 watts. Both components exceeded their published specifications. That doesn't mean the specifications are wrong. Manufacturers publish ratings that define the performance they are willing to guarantee under a wide range of operating conditions. It also doesn't mean I would design a permanent system to operate continuously above those ratings. Higher current creates more heat, more stress, and requires properly sized wiring, fuses, terminals, and disconnects. So you should always operate your systems according to the manufacturer's specifications. But as a real-world stress test, these are genuinely impressive results from affordable equipment. So, did you predict the right outcome? Let me know in the comments below. And that EcoWorthy 48-volt wall battery you saw is going to be part of my upcoming solar-powered garage air conditioning project. If you want to see whether I can run an air conditioner completely off-grid using EcoWorthy equipment, make sure you hit that subscribe button so you don't miss it. Thanks for watching, and stay charged.